got a projectile which is launched, and it's not horizontally launched, which means that finding its time is not going to be as easy, okay? But it's not horizontally launched. It's launched at some angle. And in this problem, it's also launched 16 meters off the ground, so like 4 stories up, okay? It's launched at 26 degrees with a velocity of 42 meters per second, and I want to find out a couple things. I want to know how long is it in the air, how far from the building does it land? We call that the range. So the range is the horizontal displacement of the projectile. I want to know how fast is it going when it impacts the ground. And I also want to know how high did it reach at its highest point. Those are the kinds of the things we want to know, okay? So to kind of work through that, I'll just do it by example. So the first thing, delta y. So the problem we're solving, it starts here and it ends there. So what's delta y there? Aubrey, we'll start picking on you.
Negative 16 meters.
It's negative 16, which seems a little weird because it actually went up, right? But remember, displacement is where you are at the end relative to where you started. So it's going to travel more distance than 16 meters, but its displacement is 16 meters and it's downwards. That's going to be negative 16 meters. Okay? There's a couple other freebies we know. Can you give me one there, Samuel?
Acceleration on y is negative 9.81.
Yep, and we're so tired of writing that, we're just going to put G, right?
Y.
Oh, thank you. I switched my variables. Y, negative G, or negative 9.81. Good. All right, what else do you know, Luke?
Acceleration for x is 0.
Yep. That's going to be 0 meters per second squared. Is there anything else we know right off the bat?
What's the initial? For the x.
Do we know the velocity initial in the x?
Yes.
Because this 42 is not how fast it's moving sideways. It's how fast it's moving at 26 degrees, right? So the first thing we're going to have to do is use a little bit of trig to find the components of the velocity, okay? So what we have is a ball or a cannonball being shot like this. And if there was no gravity, so I'm going to call the hypotenuse V0. That's the initial velocity. If there was no gravity, of course, that would just continue forever that way, right? But there is gravity, so that's going to change. But initially, before gravity gets very long to work on it, it's moving in that direction at 26 degrees. So what we want to do is we want to figure out how fast is it moving horizontally at that launch time, and how fast is it moving vertically. And those are just components of the vector, right? Because the x and the y direction are perpendicular, or orthogonal, as a mathematician would say. Orthogonal means perpendicular. Then you can find the velocity in the x direction initial and the velocity in the y direction initial using a little bit of trig. Okay? So because the velocity in the y direction is opposite the angle, I better put the angle in there, we're going to use sine. So the sine of the angle equals the opposite, the velocity in the y initial divided by the hypotenuse, which is the initial velocity. And that just tells us that the velocity in the y direction initial equals the initial velocity times the sine of the angle. And cosine of the angle is the adjacent side, so that's the velocity in the x initial divided by the hypotenuse, which is the initial velocity. And that tells us that the velocity in the x direction initial equals V0 cosine theta. Okay? So grab your calculator, make sure you're in degrees mode, and let's just calculate these really quickly. The initial velocity is 42, and the launch angle is 26. So 42 times the sine of 26 will be the velocity initial in the y direction. So let's just put that on there. You got it there, Madison?
18.4.
Did you use sine or cosine?
Sine.
Sine 42 times the sine of 26 is, that's about right, 18 point what?
4.
18.4 meters per second. And what's the initial velocity in the x direction? You got it, Bailey? 42 times the cosine of 26. 37.7. 37.7 meters per second. Okay? You guys see where those come from? So we found the velocity in the x direction initial, and we found the velocity in the y direction initial. So I guess I can transcribe these. This is 37.7 meters per second, and this is 18.4 meters per second. Okay? What is the final velocity in the x direction? Yeah, it never changes, right? There's no acceleration in the x, so it always equals the velocity in the x direction initial. All right, so this was the first thing we did. We found the components. And you don't need to go through all that rigmarole, okay? You can just say that velocity in the y direction initial is v0 sine theta. As long as you know the angle between the horizontal and the launch angle, okay? If you know this angle up here, that won't work, okay? All right, so that's the first thing we're going to do. The second thing we're going to do, so that was step one. We found the initial velocities. Step two, we're going to solve the y problem for the time. Because we know delta y, we know the initial velocity in the y direction, we know the acceleration in the y direction, and so we can use that second equation to solve for t, right? So I'm going to solve this equation. Delta y equals velocity in the y direction initial times the time, plus 1/2 the acceleration in the y times the time squared. I'm going to solve that for the time, okay? And because we're just going to not worry too much about algebraic solutions on that one, we're just going to use the quadratic, right? So using the quadratic equation, which Aubrey doesn't like. But we'll power through it. Okay, so let's put in what we have. Delta y is -16 equals the velocity in the y direction initial, which is 18.4 times time. 1/2 the acceleration is -4.905 t squared. Okay? That's the equation we want to solve. How do you solve it using the quadratic? You got to get 0 on one side, right? So if you're going to solve it using the quadratic, you got to rewrite it as 0 equals 16 plus 18.4t minus 4.905t squared. By the way, do you have to solve it using the quadratic? Is there any other way to solve t by graphing, by finding the roots of the polynomial on my calculator, by using the quadratic equation? It doesn't matter. Then just state the answer. So there are two solutions. T equals, what was it there? Logan?
4.47.
4.47 or 4.48?
I got 7, but probably just rounded here.
Madison, what did you have?
4.48.
Yeah. With Madison's, we put in the exact number here. So 4.48. Okay? Does that make sense? So you're just going to set up the y problem and solve it for the time. Okay, once you know the time, the next thing you can do, step 3, is find the velocity at impact, okay? So we've got to do a couple things. So we have to find the velocity in the y direction final, which equals the velocity in the y direction initial plus the acceleration times the time, and that's in the y direction. Okay? That's how fast it's moving downwards when it impacts, right? So let's figure out what that is. That's going to be 18.4. Well, the numbers are there. Plug in 18.4 plus -9.8 times the time. We've stated the equation. 25.5 meters per second, is that right? Okay. So now we've got to find the final velocity. So at the very end, it's moving like this. It's moving down and it's moving over. This is the final velocity in the y direction. This is the final velocity in the x direction, and we've got to find the vector sum of those. Okay? We call that the final velocity. So to do that, we've got to take the final velocity will equal the final velocity in the y direction squared plus the final velocity in the x direction squared, square root. Okay? So what is the final velocity in the x direction? 37.7. It never changed. Okay? The final velocity in the y direction is negative 25. Be careful on your calculators. Take negative 4 and hit the square button. What happens? It stays negative. See that? It didn't, so be careful. It should be in parentheses negative 25 squared. Right? Or you'll get the wrong answer. Alright, so what do you get when you get, what's the final velocity when it hits the ground?
Negative 45.5.
So it shouldn't have a direction.
No, it should have 45.
45.5. Anybody else get that?
Yeah.
45.5. That's meters per second. And I'm not asking it in this case, but if somebody wanted you to work out the direction, here's the horizontal. If they want to know what angle it was, you could do a little bit of trick there to find the angle, right? And it'd be a negative angle because it's below the horizontal. The AP doesn't ask for final velocities of general projectiles. I mean, they might ask magnitude, but not going to ask for direction. All right. The last thing I want to do, so we found out how long it's in the air. We found out its final velocity. Let's find out how far it goes horizontally. How can we find out the distance it goes horizontally? Well, we can evaluate delta x equals the velocity in the x direction initial times the time plus 1/2 the acceleration of the x times time squared, but of course that all is 0. And so the distance it goes horizontally will simply be the velocity in the x direction initial, which is 37.7 meters per second, times the 4.48 seconds that it's in the air. And the range of the projectile is going to be 160-ish.
168.8.
168.8. I'm going to go with 169 meters. Okay? You good so far? This isn't terrible, right? It looks like a lot, but... Okay, the last thing we want to do is find out how high it went. And this is a slightly different problem. Okay? We can't start the problem here and end it there. If you want to know how high it goes, you've got to figure out something special about that point. What is true at the highest point? Which velocity?
Final.
The overall.
So it goes up there and it stops, and then it starts going again.
Isn't it just the projectiles? It's not.
Just the vertical velocity is 0. It doesn't stop moving side to side, but it stops moving up and starts moving down. Okay? So, you've actually got a new problem. You can't use this time, and you can't use this velocity, and you can't use that time, because those were for the whole problem, right? So really, you're just going to solve a little sub-problem. So we're going to let the velocity in the y direction final equals 0, and we are going to solve delta y equals, that's not true. We're going to try to find delta y. So we're going to use velocity in the y direction final squared equals velocity in the y direction initial squared plus 2 times the acceleration in the y times delta y we're going to solve this for delta y. Okay? So if you solve that for delta y, using the final velocity in the y direction equals 0, you're going to get that point there, right? And delta y will tell you how much it goes up. So since the final velocity is 0, then delta y will equal negative velocity in the y direction initial squared over 2 times negative g. So take the velocity in the y direction initial squared divided by 2g and see what that tells you. Anybody got it? 17.3? Somebody, nobody's leaving you hanging, Lou.
I got
17.3? All right. 17.3 meters. Now, just a quick word about that. Where is 17.3 meters on this diagram? It is not that. It's how far it went up from the start of the problem. So if somebody asks, what is the final height of the projectile? You're going to have to add the 16 meters that it started at. It stopped moving upwards 17 meters above where it was launched. That maximum height, though, will be 16 plus 17.3, right? So 33.3 meters. Does that make sense? So that's how you solve general projectiles. All you're really doing is breaking the initial velocity into components, and then you have an x and a y problem. You solve the y problem for the time. It's slightly more complicated, but you've got tools to help you. Once you know the time, you can figure out how far it goes horizontally. You can figure out how fast it's going at the end of the problem. And if you want to know how high does it go, solve a different problem. Solve the problem where the final velocity in the y direction is 0. Okay? Does that all kind of make sense? So, the only way it'll really stick is if you practice it, right? So, lucky for you guys, I got some practice problems waiting for you. Okay? So, go ahead and take a crack at them. That's about, I mean, if you look at the homework, problem 1 is like part A, B, C, and D. It's really just one problem. And then part A, I asked for this, and part B, I asked for that, and part C, I asked for that, and part D, I asked for that. You just solve the problem, enter the answers. And again, make a diagram, make a list of your variables. Tell me what you are doing, but you don't need to write every single step of algebra. Tell me you're going to solve this equation and how you're going to solve it, and then do it. If I can see what you're doing and the numbers, then that's what I need.